Welcome to the Dividing Fractions Guided Notes. Let's get started. This first page is a quick review of what division actually means. Division can be thought of in two ways. Let's look at 12 divided by 3. So 12 divided by 3 can mean 12 is the total amount of items, 3 is how many groups, and 4, the answer is how many per group. We can also think of 12 divided by 3 as 12 is the total amount of items, 3 is how many per group, and the answer is how many groups, 4. Let's look at the following division problem. So 2/3 is my total amount. Divided by 1/6 means how many per group, so I'm going to have 1/6 per group, and my quotient is how many groups. We will use a visual model to make sense of these fractions. Draw two bar models that will work for both the denominators. To do so, create a bar model with one denominator as the number of rows and one denominator as the number of columns. The denominators with the problem are, so we're looking at the denominators up here. We have 1 as a 3 and 1 as a 6. So we're going to make my visual model with 3 columns and 6 rows. I could also do 6 columns and 3 rows. It doesn't matter. I make two models like that. One I use to do the problem on, and one I do to help us see the divisor. Does it matter if we had drawn 6 columns and 3 rows? No, I just talked about that. It doesn't matter if I switch those because your total 18 rectangles will be the same, and that's what you need. Now let's do the division problem 2/3 divided by 1/6. Shade the dividend on the first bar model and shade the divisor on the second bar model. So shade 2/3. I see my thirds are going this direction. So to shade 2/3, I'll shade it like this, 2/3. And then on this bar model, I need to shade 1/6. And I can see that my sixths are going horizontally. So let's shade 1/6. Now remember with division, you want to see how many times the divisor will go into the dividend. The divisor has 3 rectangles shaded in. Now look at the dividend and see how many groups of 3 are in this shaded section. So here is one group of 3, 2 groups of 3, another group of 3, and another group of 3. So that is in there 4 times. Therefore, 2/3 divided by 1/6 equals 4 because you circled 4 groups. Now we will do the following division problem. 1/3 divided by 1/4. So remember to create two bar models with the denominators as the columns and rows. So my denominators are 3 and 1/4. And so I'm going to make thirds going one way and fourths going another way. Again, it doesn't matter if you switch those. So now I'm going to shade the dividend on one bar model. 1/3. My thirds are going horizontally, so I'll shade 1/3. And my fourths are going vertically, so I'll shade 1/4. Now I want to see how many of these divisors go into the dividend. So I need to circle groups of 3. So here is one group of 3. Now here's another group of 3. So this is one whole, and this group of 3, only 1/3 is shaded. So my solution will be 1 and 1/3. Let's go to this page and answer the questions. So there are 3 rectangles shaded in the divisor, and you can go back and look at that right there. There's 3 rectangles. You need to determine how many divisors are in the dividend. Circle groups of 3 on the dividend, which we did. How many groups did you circle? We circled 1 and 1/3 groups. Therefore, 1/3 divided by 1/4 is 1 and 1/3. Model 2/3 divided by 2/5. My bar models are already made. I have thirds going one direction and I have fifths going the other direction. So the first one I'm going to shade the dividend, 2/3. My thirds are going vertically, so I'll shade this right here, 2/3, and my fifths are going horizontally, so I'll shade 2/5 right here. How many times will the divisor go into the dividend? So there's 1, 2, 3, 4, 5, 6 rectangles in my divisor. So I need to circle groups of 6. So here is one group of 6, and here is another group of 6. So this is one right here, 1, and in this group of 6, only 4 of the 6 are shaded. So 1 and 4, 6. How many times will the divisor go into the dividend? 1 and 4/6 time. And I can reduce 4/6 to 2/3 by dividing both the numerator and the denominator by 2. So 2/3 divided by 2/5 is 1 and 2/3. Model 3 divided by 1/2. So here my denominators are 1. I don't see the 1 under 3, but it's there, and a 2. So I need to divide this up with 1 and then 2 going the other way. So I will just cut these in half. Therefore, I have 1 going one direction, like 1 going horizontally, and then vertically I have 2. So now I'm going to shade the dividend and shade the divisor. So with my dividend, I have 3. So let's shade 3 whole of these. And then my divisor, I'll shade a half. How many times will the divisor go into the dividend? So I need to circle groups of a half in my dividend. So 1, 2, 3, 4, 5, 6. It will go in 6 times. So 3 divided by 1/2 equals 6. We just discovered that 3 divided by 1/2 equals 6. Notice that this is the same as 3 times 2 equals 6. 1/2 and 2 are called reciprocals. A reciprocal is when the numerator and the denominator are flipped. So it was 1/2 and it became 2 over 1. I don't write the 1, but it is 2 over 1. So if my fraction is 4/3, the reciprocal would be 3/4. If my fraction's 2/5, the reciprocal would be 5 over 2. 1/3 would become 3 over 1, except for I don't need to write 3 over 1. I could just write 3. And my 4, which should be 4 over 1, is going to become 1/4. Taking the dividend, which is my first number in the division problem, and multiplying by the reciprocal of the divisor gave us the same answer for 3 divided by 1/2. So what we are saying here is we noticed that 3 divided by 1/2 equals 6. And if I multiply by the reciprocal 3 times 2, that also gives me 6. So these are problems that we have already completed. We've already figured out that 2/3 divided by 1/6 equals 4. We figured out that 1/3 divided by 1/4 equals 1 and 1/3. And we've already determined that 2/3 divided by 2/5 is 1 and 2/3. We're going to see if this works with multiplying by the reciprocal instead, and if it gives me the same answer. So if I have 2/3, I'm going to multiply by the reciprocal of the second fraction. So 2/3 times 6, 1, and the solution to that multiplication problem, 2 times 6 is 12, 3 times 1 is 3, 12 divided by 3 equals 4. So that is the same answer I got from my model. Let's try it with this one. 1/3 divided by 1/4. So 1/3, I'm going to multiply by the reciprocal of the second number. So 4 over 1. 1 times 4 is 4. 3 times 1 is 3. And that is the same as 1 and 1/3, which is what I got from my visual model. So yes, that is the same. 2/3 divided by 2/5. So we're going to go 2/3 multiplied by the reciprocal of the second number. 2 times 5 is 10. 3 times 2 is 6. That is the same as 1 and 4/6, which is the same as 1 2/3, which is what I got on my visual model. So they are giving me the same solution. Let's use this algorithm below, then confirm our solutions with visual models. So keep the dividend, change the division to multiplication, and flip reciprocal of the divisor. Keep, change, flip. So we're going to figure out 3/4 divided by 3/8. We're going to rewrite the problem using the algorithm. So we have 3/4, we keep the first fraction, change the division to multiplication, and flip the second fraction, which is the reciprocal. Now we multiply. Remember, with fractions, you multiply across. 3 times 8 is 24. 4 times 3 is 12. 24 divided by 12 equals 2. Let's use the visual model to confirm our solution. So we are going to divide up this model into 4ths and into 8ths. Again, it doesn't matter which direction you go. I'm going to divide the model vertically into 4ths, and then let's do horizontally into 8ths. All right, my divisor is 3/4. Let's show that on the first one. My 4ths are going vertically, so this will be 3/4, and 3/8. My 8ths are going horizontally, so we'll show 3/8 right here. So I want to see how many times the dividend goes into the divisor. My dividend is 1, 2, 3, 4, 5, 6, 7, 8, 9, is 12 boxes. I'm going to circle 12 boxes on my dividend. There's one set of 12 boxes and another set of 12 boxes. So I have two sets. So I also got 2, which checks with my algorithm. 3/5 divided by 1/10. Rewrite the problem using the algorithm. So we keep the first fraction, change the division to multiplication, and flip the second fraction. Now that would be 10 over 1. I could just write 10, but we'll write 10 over 1. Multiplying across, 3 times 10 is 30. 5 times 1 is 5. So 3 divided by 5, simplified, would be 6. I'm going to model this now. I'm going to need 5ths and 10ths. So we will draw 5ths one direction and 10ths the other direction. My 5ths are going horizontally. So let's mark 3/5 as my dividend. So we'll mark one group of 1/10. So let's circle groups of 5 on my dividend. 1, 2, 3. I circled 6 groups. Is this your same solution from using the algorithm? Yes. Let's do 3/5 divided by 2/5. So first we're going to use the algorithm. So keep the first fraction, change it to multiplication, and flip the second one. 3 times 5 is 15. 5 times 2 is 10. That simplifies. I can divide the numerator and the denominator by 5, and that gives me 3/2, which is the same as 1 1/2. Now let's do this on my model. My denominators for both are 5ths, so I'm going to make columns and rows of a 5th. Let's shade 3/5, which is my dividend, one direction, and then I'll shade 2/5, my divisor, going the other direction. I want to see how many times does my divisor go into my dividend. I have 10 box shaded here on my divisors. I'm going to circle groups of 10 here on my dividend. So here is one group of 10, and here is another group of 10, except for the second group of 10, that's only 5/10 or 1/2 that's shaded. So I have 1 1/2 groups shaded, and that is the same that I got as my algorithm. Practice. Divide the following fractions. So let's do it with the algorithm, and then we'll go back and do it with the model. So 1/2 divided by 1/8 is 1/2 times the reciprocal, 8 over 1. So that's going to equal 1 times 8 is 8. 2 times 1 is 2. 8 divided by 2 is 4. Now with my model, I'm going to divide it up into halves and into 8ths. And then I'm going to shade 1/2 and then shade 1/8. I want to see how many 1/8ths are in 1/2. So I'm going to circle groups of 2 on my first model. And that is 4 groups. So I got 4 using the algorithm and the model. 3/4 divided by 1/2. So keep, change, flip. 3 times 2 is 6. 4 times 1 is 4. So 6/4 reduces to 3/2, which is the same as 1 and 1/2. Let's do it with my model. I need to divide it up into fourths and into halves. So we'll do fourths one direction and halves going the other way. Now I will shade 3/4 on my first model and 1/2 on my second model. I see there are 4 rectangles here, so I need to circle groups of 4 on my top model. So here's one group of 4, here's another group of 4, but on that second group of 4, that's only a half circled. So I got 1 1/2, which checks out for my algorithm. 3/2 divided by 3/4. Let's keep, change, flip. So keep, change, flip. 3 times 4 is 12. 3 times 2 is 6. 12 divided by 6 simplifies to 2. Let's do this on my bar model. I'm going to need halves and fourths. So let's model 3/2. So that's going to be 1, 2. It's going to need another one of those. So there's 3/2 right there. And then model 3/4 on my other one. That is 6 rectangles, so I need to circle groups of a 6. So there's one group of 6 and then another group of 6. So that's 2 groups, which is the same answer I got with my algorithm. 4/5 divided by 1/4. We're going to keep, change, flip. 4 times 4 is 16. 5 times 1 is 5. Is the same as 3 and 1/5. Let's do this with my model. So I'm going to need fifths and fourths. So let's mark 4/5 on my first one and 1/4 on my second one. So I need groups of 5. So we will go, there's a group of 5 right there. There's another group of 5 and another group of 5 right here. And then my last group of 5, which is right there, only has 1/5 of them shaded. So it's 3 holes and 1/5 shaded, which is the same thing I got with my algorithm. Okay, everybody, that's it for today. Thank you.